Okay, so we'll address measures of dispersion before we call today's class to bring today's class to a close. Measures of dispersion, otherwise called measures of variability, and you can see the measures that are here: range, deviation, variance, standard deviation, interquartile range, and coefficient of variation. So we're going to take them one after the other: range and interquartile range, then deviation, variance, standard of deviation, and coefficient of variation, in that order. Range, very easy. The difference between the largest and the smallest observations in a sample. The difference between the largest and smallest observations in a sample. So when we talk about range, we're looking at where we use the number with the smallest value, and the largest value. So the observation with the smallest value and the observation with the largest value. Subtract the smallest value from the largest value, and that is your range. I know that in English, range is from the smallest value to the largest value. So what is the range? The range is between 20 centimeters and 80 centimeters. That's what we say. That's what we have been saying. But in statistics, range is 80 centimeters minus 20 centimeters. Range is 60 centimeters. Range is a numerical value in statistics. Of course, you know that it's not sensitive to really, really insensitive. So if you have a large sample size and you have outlying values, your range will be quite wide. You have the observation with this really small value or observation with a really large high value, and you can see that your range will be really wide. If you have observations that are close to each other, your range will be small. And range tends to actually go larger the larger your sample size, because you have more values. You have more observations with more values. For you to do range, you need to order your variable, the values of the observations. You need to order it from smallest to largest, so that you can quickly identify the smallest and the largest. All right. So what we want to do is look at interquartile range. Interquartile range. The difference between the upper and lower quartiles. A quartile is 4 quartile. So when you divide your into 4 quartiles. 25 at 1/4 of the. Remember, for you to be able to do this, the observations are arranged from largest to smallest, smallest to largest. This is smallest to largest. You have to arrange them. And then you split it up into 4 groups. 4 quartiles using the formula for that, which is simply 1/4 times n plus 1, where n is your sample size. It's the number of observations. That's your n. Then 2/4, which is the same thing as half of n, gives you your second quartile, which is your first quartile is 25%, equivalent to 25%. You're going to translate it to percentile. The second quartile is equal to 50%, which is half, which is your mean. The next one is 3/4. 3/4 or 75%. And then the last one is 100%. So you break it up like that. So the difference between the lower quartile is the 1/4 and the upper quartile is the 3/4. The lower quartile is 1/4 and the upper quartile is 3/4. So the difference between the lower quartile and upper quartile difference between the lower quartile and upper quartile is what you use for interquartile range. Store this information somewhere, because when we are doing differential statistics, it will become relevant. So I would remind us most likely, and we'll come back here. What's deviation? Deviation. The difference between the mean value and the specific observation, the value of the specific observation. So each observation in a sample, each observation has value, and each of these values differ from the mean value by a certain number. So for you to find what that is, you would subtract the mean from the value. I think that the best thing to do for this to make sense is to give some examples. Let's assume that the mean age in this class is 30. Let's assume, it may not be, but likely not to be, but let's assume that the mean age is 30. If your mean age is 30, and then you have 5 of you in this class, 36, 42, 24, 28, and 32, something like that. So if your mean is 30, the person who is 28, whose age is 28, what is the deviation between 28 and 30? It's 28 minus 30. Deviation is -2. The person who is 32, what is the deviation? It's 32 minus 30 is 2. Person who is 36, the deviation is 36 minus 36. If you add up the sum of all deviations, if you add up, let's say add up the sum, if you add up all the deviations, you will get 0 around the mean. For any data set, you will get 0. Just check it. Now that is why deviation by itself is not very useful to us, but the way around it, statisticians have found out, is that you square the deviations. If you square it and you add it up, it will not be 0, because that square, the reason why it's 0 is that because you have some values that lie to the right of the mean and some values lie to the left of the mean, and by the time you bring in the deviations together, it cancels it out. You see negative, minus, adding to plus, and it just cancels it out. So we prefer to square the deviations because we need that to be able to go to the next level of measurement of variability. And so that is what brings us to the concept of variance. Variance is the average of the squared deviations of the data from the mean. Average of the squared deviations of the data from the mean. Let's look at this formula, the formula in this diagram. I just need you to understand it. If you felt it, you need to calm it, but if you understand it, then it's easier. All right, so remember, this sigma sign is summation. My cursor is there. So S squared is variance. S squared is variance. And why are we squaring? Because if we just do direct, I said deviation, it will give us 0. So we have to square it to convert all the negatives to positives so that it makes sense. So, and if you are squaring the deviations, then your answer for it also makes sense, will also be squared. So summation, x, which is the individual observation, minus the mean, in bracket, squared, divided by n. It should be n, which is the sample size, but we do not use n, we use n minus 1. That is where the word degree of freedom comes from. If you've heard that word degree of freedom before in statistics, please just put a yes in the chat box. I have heard the word degree of freedom. If you've never heard about it, put a no, because I want to go into an explanation of degree of freedom, but I need your feedback to be able to know what I am doing. All right. If you've heard of degree of freedom before, put in a yes. If you've never heard of it, put in a no. I want to see if we're here for you. Just type into the chat box, please. All right, I'm seeing some responses. I need a few more. Know what direction I'm going to take with this. Okay. Stefan, we're not fighting. The degree of freedom. All right, okay, that's fine. So let me explain degree of freedom. So why are we using n minus 1? Why are we not using n? Remember, n is the sample size. N minus 1 is the total number in your sample, total number of sample, total number of units in your sample minus 1. That the reason is that there is one value that will not vary. Degree of freedom is the number of values in a study sample that has the potential, or that you can actually even observe, to assume a value that can deviate from the mean, from the central measurement, from the mean, or from whatever you're using as your measure of central tendency, whether it's mean, whether it's median. Those are the two commonest things. We don't use mean, we use median. There are values that can, what number of values can deviate from the mean value, can move, have what it takes to move from the mean value. And the teaching is that all the values minus 1 value, all the values minus 1 minus the value of 1 unit can change, can deviate, can vary, have the freedom to vary. One value, at least one value, will not have the freedom to move. So let me give you an example. If you remember musical chairs, when we're growing up, all the musical chairs, when we go to a party, we say, oh, yeah, musical chairs, we want to know the winner. There are 5 of you dancing, they will put only 4 chairs. There are 5 of you dancing, they'll put only 4 chairs. At any particular point in time, 5 of you dancing, there are 4 chairs. Only 4 of you have the ability to sit on the chair. One person will not sit. And that is how the music of 4 people will scramble and be able to get it. One person will not be able to get it, another person is out of the game. Doesn't make sense for the 4 people to be dancing or 5 people to be dancing around 5 chairs. No. So it's the same thing. In trying to, and this is a statistical rule, is a law. That's where degree of freedom came from. In trying to have a relationship with the measure of central tendency, all the values in a data set can assume a relationship with the measure of central tendency, except one. And that is why, and you have to take that into consideration when you're doing your statistical analysis. And that is why there's n minus 1. It's called the degree of freedom. So we don't use the exact sample size. We usually would remove 1 from it, accounting for that particular value that is unable to deviate. Usually representing either the mean value or a value that is closest to the mean. It really cannot deviate. All right, so that's just me trying to explain degree of freedom. But most people just look at the formula and just know there's n minus 1. If it, all I've said still doesn't make sense to you, just receive it by faith. I just know that the statistics have some queer things they do, statisticians have some queer things they do. Instead of saying minus n, instead of saying divided by n minus 1, you accept it like that. Know what they do. They must be intelligent people. That's okay. So this is variance. Summation of individual. So summation means you're adding up. So if there are 20 variables, if there are 20 study units, 20 observations, 20 values, value 1 minus mean plus value 2 minus mean plus value 3 minus mean plus value 4 minus mean, like that. Square, added up together, summation. Divided by the sample size, which is n minus 1. And that gives you your variance. So this is the formula for variance. But what really, it's actually the squared deviations from the mean, squared deviations from the mean. So the sum, the average squared deviations from the mean. The average squared deviations from the mean. Really tough to make sense of it until you do this. Standard deviation. Standard deviation. So because we had squared it so that it makes sense for the mathematics, we need to do the square root to bring it back to a value that makes practical sense. That makes practical sense. So it is the square root of the average deviations from the mean. It's the square root of the average deviations from the mean. So see the same formula as you saw in variance. The only difference is that it has lost its square because, and then here now we have a square root. And here now you have a square root. This is standard deviation. This is standard deviation. So standard deviation is the square root of the average deviations of data from the mean. Square root of the average deviations of data from the mean. Now when we're doing the normal distribution curve, this will make some more sense to us, because if you have ever seen the normal distribution curve, otherwise known as the Gaussian curve, you will know that most data sets, especially the data sets that measure biological variability, biological data information, follow a normal distribution curve, where majority of the values cluster between 1 and 2 standard deviations from the mean. Majority of the values cluster between 1 and 2 standard deviations, and even 3. So all the values of a particular data set, 90-something% of the values, I will say the exact number of values in a particular data set, can be seen as occupying a variability within 2 to 3 standard deviations from the mean. I will see that more fully when we are doing the normal distribution curve, before we actually get into inferential statistics. Okay. The last one in the list of measures of variability or measures of dispersion is the coefficient of variation. So you are expressing standard deviation as a percentage of the sample mean. So you've done your standard deviation and you just divide it by your mean and multiply by 100%. Standard deviation divided by mean times 100% gives you your coefficient of variation. All right. Now, let's see how we can take this, and then we would to see how this helps us understand what we have studied so far. And maybe I will look for some exercises for us to do as a kind of like a small assignment to help us understand this even further. All right. So these are your individual values. These are your individual values. 1, 2, 3, 4, 5. So your sample has 5 study units, 5 observations. Therefore, your N is 5. Sample size is 5. These are the individual values. The first one is 3, 4, then 5, then 6, then 7. These are could have been any values. These are the individual observations. Maybe it is kilograms. Maybe let's look at the weight of something. Maybe it's kg. Maybe it is height. Whatever it is, your individual values, this is it. And by the time you add them together, they come to 25. Come out to 25. Summation, that's why you have summation x is equal to 25. That's why you have summation x is equal to 25. You add all up together. X bar, which is your mean, is the total number divided by the sample size. That is why you have 25 over 5 is equal to 5. I'm sure this is very easy and straightforward so far. All right. Let's look at the deviation from the mean. Since we know that the mean is 5, 3 minus 5 is minus 2, 4 minus 5 is minus 1, 5 minus 5 is 0, 6 minus 5 is 1, 7 minus 5 is 2. If you add it up true to the law that the deviations around the mean is always 0. This is minus 3, this is plus 3. Minus 3 plus 3 is 0. Cancels out. Can we please state that you are following me so far? So because it cancels out to 0, there isn't much we can do about it. So we're going to square it. We're going to square it. So minus 2 times minus 2 is 4. Everything you do that the negative sign when you square it, removes the negative and so on and so forth. So you have 4, you have 1 because 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So 4 plus 4, 8 plus 9 plus 1, 9 plus 1, 10. So your squared deviation from the mean is your squared deviation from the mean is 10. Your variance, which is the summation of your squared deviations from the mean, is 10. Variance, which is the summation of your squared deviations from the mean, is 10. Your standard deviation, so you can see your variance is 10. The standard deviation, which is your variance divided by your squared deviations from the mean, is your variance, divided by n minus 1. Remember, your n is 5. You've taken 1 from it, and that's what makes it 4. Let me take you back to the formula. 1 second. This top part of the formula, what is it? Variance. Look at it. This is it. Variance, and you just square it. Just do your square root of it. So this is 10. This is 10 that we've got from the table, divided by 4, and you find your square root. So let's go back. So this is 10 divided by 4, which is your variance. S squared is variance, which is 10 divided by 4. Remember, 10 and divided by n minus 1. 10 divided by 4 is 2.5. So your variance is 2.5. What is your standard deviation? The square root of variance. So square root of 2.5 is 1.6. The square root of 2.5 is 1.6. I want us to go further and calculate the coefficient of variance. Let me take you back. Remember, your standard deviation is 1.6. The sample size is 5. The sample size is 5. So can somebody please calculate? The standard deviation is 1.6. The sample size, your mean is 5. Multiplied by 100. What's the coefficient of variance? It's not here. So I think we can calculate that by ourselves and for ourselves. So help. Let's take it a step further. I want you to calculate the coefficient of variance. Since you know that the standard deviation is 1.6, you know that the mean is 5. All you need to do is 1.6 divided by 5 times 100. What do we get? Answer, please.
32, ma.
Thank you very much. Can we put it in the chat box? Put in your answers in the chat box.
All right, ma.
What percent? Remember, you multiplied by 100, so it's percentage. Correct. 32%. Yes. All right, cool. Okay. Thank you very much. I think that makes sense. I will send you something similar, a table that is similar to this. And I'd like you to do the calculation and send back to me before our next class, which is next week, Wednesday. So I'll set up how that can be, done.